All right, folks, I'm going to do 6.3 here for Algebra 2. And I want to make this as simple as possible for you guys and also covering what we need to cover. So first of all, we are in square root functions. So we have square root functions. And what's a square root function? Well, has a square root in it. Let's go y equals square root of, let's say, x plus 2. Now, we all know that we have something called parent functions. I've talked about parent functions before. Our parent function for this unit is y equals root x. So that's our parent function right there. Every other function that we have kind of stems from this function. And we are trying to figure out how do these functions that I'm giving you change from our parent function. So I'm going to label this our, this is our parent function. All right, so let's take our new function here, y equals root x plus 2. We have a radical sign right here, and a y equals, this could also be known as f of x, or g of x, or h of x, or whatever variables we want to put in there. So, things that we also want to know. We want to know domain. We want to know range. Let's refresh our memory. Domain. What are all the possible x values that a domain can be? Range. What are all the possible y values? And you guys know I usually denotate the domain and range with a D and an R right there. So let's take this function. Let's find the domain of this function. Now, all the possible values here. Well, we know that inside a radical sign, this cannot be negative. So if that cannot be negative, we have to find where does x plus 2 have to be greater than or equal to 0. Solving for our domain, we subtract 2 from both sides, and we have x is greater than or equal to negative 2. And that is our domain of our function. Now, we also need to know our range. So here, with no other numbers besides the radical here, that also cannot be negative. Now, if we had more numbers out here, like a k or a c value right there, then yes, it would be negative. But underneath the radical, this cannot be negative. So our range for this function, let's put it right here. I'll put it right here. Our range is y has to be greater than or equal to 0. And that is our domain and range. Now, you can also think of this as what we've learned before as whatever the number is out here or out here, remember that? That's going to be our range. So if we had a plus 2, our range would be y is greater than or equal to 2. If we had a minus 3, our range would be y is greater than or equal to negative 3. So to find the domain, set what is underneath the radical sign greater than or equal to 0. And to find the range, set y greater than or equal to whatever number is out here. And if the number does not exist, it is 0. Let's next talk about transformations. Now, we've talked about these before with other functions that we've worked with. Talked about the k value, the h value. Now, let's talk through this. All right. We have our x minus h right here. Well, anything under parentheses lies. So, as a reminder, I'll come over here real quick. Parentheses or radical signs always lie. Parentheses always lie. Now, that kind of deals with this right here. So, if we have an x minus h, if it is minus h, then we are going to be shifting right because h right here is going to be greater than 0. If it is plus h, our h is going to be less than 0, and we are going to shift left. In other words, if you're subtracting h, do the opposite, shift right. If you are adding h, do the opposite, shift left. What about outside the radical? Now this k value is outside the radical. We know that k value also determines the range, which makes sense because it moves up or down. If something is outside the radical, we are moving up or down. If it's being subtracted, moves down. If it's being added, it moves up. So this tells the truth, that lies. Our next one here is an a value, similar to the other functions. If a is less than 0, if it's negative, it's going to be a reflection over the x-axis. If a is greater than 1, it is going to be stretched. If a is between 0 and 1, so if it's going to be a fraction, it's going to be compressed. Our last thing that we've done before is a vertex. Our vertex is always going to be opposite h, same as k. So if we have a function over here, we have, let's use f of x equals, let's go the original one we actually used. So let's go back over there and let's look at our x plus 2. We have x plus 2. Let's add on, for simplicity's sake, a plus 3. All right. So where does this shift from our parent function? From our parent function, this is going to shift to, so this shifts to the left. It shifts 3 up. It is not reflected, stretched, or compressed. However, let's add in a negative here. If this is a negative, that would mean that it is reflected across the x-axis. All right. What is the vertex of this? Well, our vertex, we are going to look at the opposite h. So if we have a positive 2 here, opposite h is going to be negative 2 and positive 3. Let's see how this exact equation right here looks in our calculator. So I'm going to go to our calculator and go over here, and I am going to go to, I was doing things earlier, that's our parent function. Let's go equals negatives down here, square root of x plus 2, and then plus 3. So our first one you see graphed is going to be our regular parent function, root x. And that is our second one that you see. Our second one that you saw was our negative root of x plus 2 and then plus 3. Now, what if it is going to be stretched or compressed? What would that look like? Well, if a is greater than 1, let's say this is going to be 4 times root x. And our third one here is going to be, let's go 1/2, less than 1, but bigger than 0, times root x. What happens? Well, our first one is our parent function. Next, it is stretched. And the third one is compressed. And as you can tell, all of our vertexes right there are 0, 0, 0. And our previous vertex, I forgot to show you, was that negative 2, 3 that we saw. All right, folks, that kind of wraps up everything. So again, here are our notes for 6.3, if you were following along. And I will leave you with all of the rules right there. If you can take a screenshot of that, that would be awesome. All right, have a great day.